Welcome back, everybody. You got Will and I Man here from the Block Runner, MetaZone, Rovi, and Mscribe. Today, we're dropping digital matter theory. Framework.
Actually dropping it, right?
Yeah, it's today, dude.
So we're not just dropping like an AI rendered image in representation of DMT and like talking about it.
Yeah.
We're actually trying to be about it this time, right?
Did we ever drop an AI image of
Remember
this?
the pyramid, the cone?
Oh, yeah.
That was a thumbnail to like the introduction of digital matter theory concept.
That's right. Yeah, that's right.
And we started to look over like some applications of it that we were witnessing specifically around bitmap.
Yeah.
And then we developed like this umbrella like understanding around what it is that we were starting to identify as like this new value layer emerging from blockchain, right?
Correct.
We really honed in on it once we saw bitmap, but
Yeah.
this is like an actual like real premise behind this theory that we've kind of we've been spending a lot of time like refining.
Yeah. And this is more of a discovery rather than like an engineering.
Yeah.
Right. And we'll explain what that means kind of like in context with all this. But yeah, we were trying to figure out, it's like, why were we able to so instantly like recognize the value of a bitmap? I mean, other than the fact that we had 4 years of experience in like the Web3 metaverse, like we were able to intuitively pick up the value of it. But outside of that, it was because bitmap was non-arbitrary.
Yeah.
And so then it was like, okay, what else in the space is non-arbitrary? It's like, well, we got rare sats. Rare sats is like the recognition of a position of a Satoshi and attributing some sort of value to its position.
Yeah.
Right. And the position is the pattern.
Yeah.
Right. And then ordinals, Casey Rottermore discovered another pattern. He was like, hey, sats enter in a sequence chronologically.
Yeah.
Let's just give that sequence an ID.
Correct.
And then let's allow people to do stuff with it. And now we have ordinals.
Yeah.
So with digital matter theory, it takes the value propositions, the value asset foundation, and creates a framework for anybody to create these non-arbitrary tokens.
Yeah. So, yeah, we really, I guess, so we've seen, I guess, like a behavioral pattern, which is the recognition of patterns itself, right? And then applying a new value layer on top of that. So we really want to see that, I guess, proliferate as much as possible. And it's kind of like has eerie like reminiscence of like early NFT days where digital collectibles were obviously a good idea, right? It's like an emerging practice. Like, let's create, let's utilize, implementing arbitrary information in order to, I mean, in this case, point to the existence of some sort of file that is stored somewhere to represent the ownership of a digital collectible, right?
Yeah.
And that concept, in the early days, there was multiple attempts at trying to do that. But the thing that was missing was a unified method for creators to basically, engage in this practice. So in the absence of a standard or a framework, there's fragmentation.
That's right.
Right. That's just always an issue. Bitmap is working to solve that with the bitmap standard itself.
That's right.
Trying to like reduce the fragmentation of the effort of making a metaverse and bringing it into a unified consensus.
Yeah.
That is what bitmap represents. So it's like we kind of want to do the same thing for this non-arbitrary value creation space, right?
Yeah.
The pattern recognition space, right? So that has been like our real motivation, our goal for all of this.
Yeah, and in the context of bitmap, this is such a big deal because we don't have to convince anybody that the data that bitmap is relying on, they don't have to agree on that. It just is there, right?
Yeah.
And so now if as a developer and a creator wanted to build something for the metaverse, well, you leverage that data because it's non-arbitrary. It's there for you to use.
Correct.
And it doesn't take like a consensus. It's already there.
Yeah.
Right. And so it's unlike, existing metaverses where just arbitrary decisions have been made back to back to lead to what it is. And so just leveraging that and platformatizing that is where we see a ton of value. And and we tweeted this picture a few hours ago. And so I think it makes sense to kind of go through this picture to kind of kick things off.
It's like a little history lesson, right? You're going to take us down a little journey.
Let's take everybody down a journey
Okay.
here. And Bitcoin obviously was the first cryptocurrency, right? It's been going for over 14 years and it's still every 10 minutes beating, right?
Yeah.
Then a few years later, Ethereum, and then we have, all the manias that we've seen so far.
So 15 years of what we've labeled as arbitrary token genesis, essentially. It's been like an era of, setting specifically for the formation or creation of a new digital asset, the parameter set of, I guess, the qualifications of the existence of these tokens itself are just pulled out of thin air.
Mm-hmm.
Some deployer, some human out there
That's
just arbitrarily, Satoshi himself, 21 million,
Mm-hmm.
you know, it's just a number just extracted out of nothingness. Maybe
Yeah.
there's some sort of like theoretical support behind this decision. Nonetheless, it's still arbitrary at the end of the day.
Even if there's nothing to support 21 millions,
Right.
It could have been easily 50 million.
As we've seen, we've seen all kinds of experiments and attempts at creating arbitrary, I guess, like token parameters and seeing, you know, what kind of ecosystems can flourish as a result. We got tokens in the trillions and quadrillions out there.
Yeah, sats.
Sats.
Yeah.
On ordinals, BRC20, 2.1 quadrillion, right?
Yeah, that's right.
Yeah, it's a shit ton of tokens, but
Yeah.
we're as collective participants in this like token space, we're trying to see what kind of ecosystems can, you know, emerge from that. So
Yeah.
all we're saying is here now there's an opportunity through the recognition of patterns and registering of them. We've created like a whole process to where now you can kind of reference the existence of these patterns that are, like you said, they're discoverable, right?
Yeah, that's right.
You're not engineering the existence of these things.
Yeah.
They've been provided through the many years of blockchain activity that's
right.
specifically on Bitcoin.
Yeah.
And you could use that now, harness that as now like a non-arbitrary route of information to set these parameters for token genesis, right? So,
And the cool thing is anyone can go and discover these.
yeah.
Right. And if you're the first to discover it, you get the rights to name it. And so we're going to go through all those details a little bit later.
Okay, let's okay, so there's a fork in the road, obviously.
Yeah.
So it started with ordinals, right?
Yeah, all of a sudden Casey Rodimer says, hey, you know, these Satoshi sequence, let's give everything an ID and let's start this thing, right? So boom, Bitcoin explodes in terms of like creativity, creation.
Yeah.
We got pictures, we got all kinds of stuff happening on.
And we've talked about this a lot on this podcast. Like why did ordinals of all things kind of like have this gravitational pull? Because this isn't like the first time.
Yeah, counterparty.
Yeah, counterparty, colored coins, whatever, stamps. Like this, there's tons of other like emerging, I guess like token generation methods emerging on Bitcoin. But for whatever reason, something about ordinals has like an innate property to it. I think a lot of people haven't like identified what it is about ordinals that makes it so attractive and alluring.
And it's the fact that it's a recognition of a pattern. Yeah. It's really that simple. Yeah. Like that's the narrative that people can innately just gravitate to, because we were talking about this. The reason why humans are still here is because we can do pattern recognition. And if we couldn't do pattern recognition, we would have been killed by lions a long time ago. Yeah, we wouldn't have been able to like deduce. It's like, you know what? I should probably stay away from things with sharp teeth. Yeah. Yeah. They tend to fuck people up pretty often, you know, but I'm able to see that pattern in the wild, in the wilderness, and then I guess like create some new value for myself as a species, right? Yeah. Stay away from them sharp teeths. You know what I mean? Exactly. So yeah, obviously it's an embedded like biological program rooted in all of our, you know, our brains. Yeah. Our just like makeup, our genetic makeup. Yeah. So, okay, so then ordinals pops off, and of course, you can still create arbitrary stuff, right? There's 10K PFP projects, there's unlimited BRC20s now, they'll randomly generate out of thin air. Yeah, clearly it's not like this arbitrary road has been like a failure. Yeah, no. This has been a tremendous success story. Correct. Creating digital value out of arbitrary means. So it's not saying like it's invalid in any way. Correct. Right? Yeah, I mean, we couldn't do non-arbitrary without the arbitrary. Exactly. Yeah. You needed an arbitrary, I guess, root source of data, that data layer that we could tap into. So in other words, like the last 15 years on Bitcoin this is like now like the fabric of I guess information. Kind of like there's an information fabric out there in the physical reality sense. Yeah. It's kind of like an unexplored like territory of physics, I guess. You know, some people are postulating that dark matter is that. It's just like this like information that we can't really quantify. Yeah. But that's why the universe is like forever expanding, because the information of it's like the universe could be a computer because of the information the universe continually grows, just like a blockchain does. That's right. So like, why are we expanding? Well, maybe the fabric of the universe is just a storage of information. That's right. I mean, that is a real physics theory. It is. Yeah. And then we're like, damn, dude, what if we kind of like bring some of these principles into the virtual, you know, existence layer, which
people are labeling as the metaverse and such.
Yeah.
But yeah, I mean, basically the digital creation space, right? We have the potential to kind of, again, harness the fabric of the digital space, which is the information layer, and create new value out of that. So
yeah, and so from the existence of ordinals, we had, I guess, a community formed based on rare sats. And so this community formed because they recognized a pattern of a position of a sat, right? And soon after, bitmap was born.
Yeah.
Right. Bitoshi Blockimoto, same thing, recognizes a pattern. Every block is really a district in the metaverse, and the transactions of parcels.
Correct.
Right. Another recognition of pattern. And so, and then this framework that we're going to talk about is the culmination of like the why these things have value. Right. And then we're just packaging up in a framework, open source, anybody can use it. Apply that to different chains, whatever you want to do, you can do. Yeah. And but in this document, we're going to apply DMT to Bitcoin.
Okay.
And so now we're in this fork where, as a creator, as a project generator, you can decide to create arbitrary tokens, or using the framework, create non-arbitrary tokens for fungible and non-fungible versions.
Correct. So hence this graphic, dude. Truly is like the first time we've seen like a fork in the road in the, I guess what we're labeling as the digital like substance, I guess generation
era.
space. Yeah. So up until now, there's only been really one option. It's like, you got to create digital matter out of like, arbitrary methods. Yeah. But now we have an alternate. We have two options now as an ecosystem designer, creator, whatever. Yeah. Now we have a whole new avenue to kind of like tinker and experiment with and explore and see like what can we do? How can we like strengthen the sustainability or the authenticity of an ecosystem like around all of these like now non-arbitrary principles, right? Like it's very unexplored, and we're not going to sit here and try and predict exactly like all the value adds the adopters of this are going to come up with.
Yeah, it's like saying
it's impossible.
Casey Rodimer coming up with ordinals and him predicting the metaverse is going to spawn here.
Yeah, I don't think he wouldn't have expected that.
No.
So yeah, I mean, the point is, you said it best. Like what we want this to turn into is like what did you say? A weapon of mass creation.
That's right.
That's what we want this to be. It's like people to kind of like understand this at a conceptual level. I guess if you find value in this and you think this can contribute more value to this Web3 space we're all like building within, leverage this, try it out, experiment with it, and see what you can create from it, right? That's why we've, set forth at least like some sort of groundwork, foundation to this all, right?
Yeah, and this can be contributed to by the community. If they say, hey, you need to add this because of that, and people agree and they want to use it for their project, then we can update this document and, anything. But so, Iman, what is digital matter theory? It says the basic premise is DMT proposes that it is possible to create a form of digital substance by leveraging the inherent patterns present in data. So the fundamental concepts, patterns in data, the theory suggests that data, when analyzed and interpreted, reveals underlying patterns. These patterns could be harnessed to generate digital substances. So what are digital substances? Refers to a computational or information-based material that exhibits properties akin to physical matter. The substance may not have a physical presence, but can be manipulated and interacted with within a digital environment.
Yeah, so I guess we could speak on a little bit about like maybe like the origin story of like how this even came to be, because obviously, a lot of it originated from bitmap, right? And we kind of wanted to figure out a way how to create like a digital commodities, or like to discover digital commodities from bitmap itself. And then we kind of started coming up with this concept of digital matter theory. It's like this is like a process of creating digital materialization, right? What are commodities in the physical world? Things like gold, things like, all the elements that make up all of the different complex, materials in our physical reality. There are existing laws that we had no influence on. Those are the non-arbitrary parameters of physical reality.
It's called physics.
It's called physics. There's people who are actually actively out there, again, looking for patterns in the universe.
100%.
To, I guess, so we can understand and harness physics to our benefit, right?
Yeah, thank you, Neil. deGrasse
Who?
Tyson.
Neil.
Yeah.
I thought you were gonna say like, I don't know, fucking Isaac Newton or something. not the star guy. But yeah, you know what I mean.
Yeah.
And damn, where was I going? Oh yeah, so then we thought like this concept seems like too big, and we don't want to like limit it just to like a token generation.
Yeah.
Like concept, right? We want like the identification of patterns that have much broader applicability that we can't even foresee at the moment, right?
Yeah, 100%. So DMT has absolutely nothing to do with Bitcoin. It is the theory of pattern recognition and then applying that to something.
Something of like, substantive generation.
Something of use.
Something.
Right?
Yeah. If you could think of, if you had like godlike powers, what would you create, basically? And if your only source of like resource to create is, it's rooted in non-arbitrary means, through non-arbitrary means. You know what I mean?
Yeah, it's a challenge.
Of course, but it's open to interpretation, and we've seen the application of DMT out within bitmap. Like we've seen generative like 3D renderings and stuff like that.
That's true. Yeah.
Within the bitmap ecosystem, we've seen generative art based on like, again, data parameters that exist within bitmaps and such. So
yeah,
it's very broadly applicable. But you're right. Like we have a very specific like showcase here, like how it can be very like purposed for a specific use case. Right?
Yeah, and in this case, we're applying digital matter theory to Bitcoin. That's why the next section says applying DMT to Bitcoin.
Yeah. So
we have this amazing graphic here. It took quite some time to really conceptualize this in like a simple graphic. But what we're looking at here is we have the existence of Bitcoin data, right? Roughly 15 years of data.
Yeah.
And what we're going to be doing is allowing the community to come up with what we call elements. And elements is a way that we formalize a pattern recognition into an inscription.
Okay.
And once these patterns are recognized, projects, creators, developers, they will point to that element for provenance. They'll point to that element, and they will create whatever it is that they want to create, a PFP project, some game for the metaverse, a game disconnected from the metaverse. It could be any project, art project, DeFi.
Yeah.
DeFi can be leveraged here. And so you would deploy inscription pointing to the element, and then now your community who likes what you're doing, they'll go in and inscribe your token, your non-arbitrary token associated with your project.
Correct. Yeah.
And that's it. And so you can imagine a single element that gets really popular have thousands of different projects.
Oh, I could definitely see that.
Right?
Without a doubt. Like, and so we're going to get into it in a second here. Like, what's the actual, like, practice of parsing through data in order to, like, I guess, recognize a pattern? We've actually given that a label as well. Yeah. But you can imagine like somebody with a lot of gravity to their brand or name, like Yuga Labs or something like that, right? Somebody could postulate that there has to be some sort of pattern within the data of Bitcoin that I can register and point to as like that represents Yuga, or like an ape. Yeah. Right. And you can imagine a lot of other people would be interested to point at the existence of that same pattern to derive new, ecosystem value from that. So that's what you're saying. Like we've enabled that to happen. Yeah. With the element registry.
Yeah. And there's going to be on-chain provenance, and some projects are going to say if you own an element, you're lucky because every transaction you get a cut or something. It's going to be totally just up to like, for platforms and projects to come up with ways to incentivize, support, whatever it is. But anything's pretty up for grabs here. So we talk about history here, and the link for this obviously will be in the description because we want you guys to read it, apply it, start finding patterns within Bitcoin, inscribing those patterns, and creating projects out of it. So why non-arbitrary creation matters, right? We have authenticity and provenance. We have unique and novel outputs, efficient creation, and then reduced subjectivity.
Yeah, I think that's probably like the most interesting, I guess, like vector of, again, ecosystem experimentation. Like, let's see what happens when because we've seen it like in the NFT space where, arbitrarily 10,000 mints of an art piece just became like this thing that we gravitated towards. It's like, this is a good ecosystem model for whatever in this space at this given time. So the arbitrary process of like introducing new supply into this ecosystem for whatever reason, in most cases it's, you know, the organization that's issuing this art, it's like a funding mechanism for them or whatever.
Yeah.
But typically that really takes like the community and the ecosystem by surprise.
Yeah.
It's like a supply shock, and then it just has really negative, you know, economic consequences, right?
Yeah, we've seen that a number of times already.
We have. So obviously there's an issue with like arbitrary issuance of supply.
Yeah.
So it would make a lot more sense if you could devise an ecosystem and attract and onboard participants within this ecosystem by kind of like presetting an already like a agreed upon expectation of whenever new supply is introduced into the population pool.
Right.
And it's going to be dependent on non-arbitrary existence of patterns, right? Whoa, that was cool.
Sorry.
Something big just happened there, right?
Yeah.
So we're going to explain what just happened in a little bit. But yeah, again, this is what I want to see, like different ecosystem creators experiment in this, reducing the subjectivity of like, you know, when to manipulate things from an economics perspective.
Yeah, it's such a big deal. It's kind of hard to like encompass how important that is.
Yeah.
In this video, but we're going to be continuously talking about this throughout the next few weeks because there's so much to talk about, right?
Yeah, I know. Of course, we hear you guys. We want to talk about stamps.
Yeah.
And I know you guys really want us to chime in on BMP tokens and stuff.
Which we will, but not at this moment.
Yeah, we just have to like really get this out.
Yeah.
So we could look at everything else.
All right, I want to read this part here. So the motivation. The following draft intends to introduce standard specifications and methodology to identify and register through the act of inscribing discoverable patterns within stored Bitcoin block data. These registered elements will serve as reference IDs to be called upon when generating non-arbitrary token parameters that can then be applied in the digital token creation process. And most important here, it says, this is an open source experimental framework. Use at your own risk.
All right. So if you've already been properly spooked at this point, I guess don't click on the next page.
Yeah.
Just, I guess this isn't for you,
like,
dude.
Make sure you're at least 18 years old.
Yeah. Make sure.
All right. So we're not going to go through like all the bits here, but this document, I'm telling you guys, you need to read this because it gives you context to like what the hell we're going to be talking about.
Yeah, we did a lot of like, again, new conceptual introduction, new terminologies and stuff like this. There is a lot. Yeah. This is we received feedback from some people who've already read it. It's like, it's a lot.
It's a lot, but it's also a banger.
I think so.
Yeah.
Let's see.
All right. So how do you register an element, right? So formal pattern recognition, inscribing a dot element inscription using the following format. So this is where it starts. Right. So if you are a Bitcoin native, you know that there's fields within a block data and you need to pick a field.
Yeah.
Right. Then of that field, you can pick a pattern, which this is optional and it's explained down here in this table. So a pattern is optional and we'll explain why. But then if you're the first to inscribe this particular pattern or, you know, this particular field, you get to name it. Right. First is first. And it's like basically discovering a star in the sky. You get the rights to name that star, and forever you've named it.
Okay,
right?
So there can't be duplicates, right? Like even you can't have like field 10 and like pattern of 6261 more than once, right?
I mean, technically,
even if you have a different name,
it can be correct. Right? Correct.
Yeah.
Yeah. So. It can be inscribed multiple times, but first is first, and the first one is just the one that counts, right?
Yeah.
So just to give a little bit more detail, their names are not case sensitive, so Doge equals Doge. So yeah. So the reason why the pattern isn't required, it's optional, is because in some cases you just want to invoke the field of a Bitcoin data. So, and we're going to show one of the fields being invoked in the first element deployed that we just have a field deployed and that's it. So it's like we gave it a name, it's a field, it's a dot element, and that means that the data within that field is what we're going to use as the first non-arbitrary token.
Yeah, that makes sense. So
and then for demonstration,
there are several, like, because these these fields have, I think, multiple like data formats, right?
Yeah, exactly. So these fields consist of, which of course we put it all together here, about 37 different fields, right? It includes Coinbase, a block hash, transaction hashes, everything is all there, right? So you guys get to decide which field you want to use for your particular element. Hopefully it hasn't been inscribed already. And then you get to name that, right? And so everything's here for you. And then, of course, we got to mention track. So Benny, we've been collaborating with Benny on this endeavor here.
Yeah.
And, of course, he's looked at it. He loves it. He's been talking about digital matter theory here in some of his podcast like appearances. And he's going to be indexing all the elements, all the deploy inscriptions, all the mint inscriptions, and all the transfer inscriptions under the TAP protocol.
Correct. For good reason, right? Because like we talked about before, one of the big like introductions of, I guess, this token ecosystem is the fact that these aren't like static tokens. They're new entrants of supply can occur depending on the block introduction, right? A new pattern can be introduced anytime a new block gets minted, right? Like, hey, this sequence occurred again, so therefore now there's more, ownable assets to this. So the existing tokenization standards in the Bitcoin space specifically, they don't really support that type of expansionary supply, right? So we needed a functional token generation platform, which TAP provides.
Yeah, so essentially BRC20s, atomicals, basically any fungible token standard that we've seen on Bitcoin does not account for an expansionary supply. I say expansionary because this is actually a positive thing. The negative connotation of expansion is inflation, right? But Bitcoin is quote-unquote inflating, but it's good. It's actually a good thing because the consequence of that is that 1,000 years from now, new people can be onboarded into the bitmap ecosystem, and they can participate equally as you and I are participating in the bitmap ecosystem.
Yeah, so it's kind of like a built-in future-proof mechanism, right? Just to ensure that, specifically for the metaverse, because it is going to be like an onboarding effort to get like, a majority of human beings as, persistent participants in these virtual spaces. So yeah, you don't want to limit and create too much restriction access to that, right?
Right.
So yeah, a little bit of that is incorporated. So yeah, the dynamics of, I guess, function enablement are required, right? And right now TAP is on the forefront of I guess bringing that into the token environment on top of Bitcoin, right? So, and on top of that, of course, indexing is critical to all of this. If we want an actual like ecosystem to flourish and emerge from this, we need like a reliable indexing support. Yeah. Right. And what better than track?
Yeah.
Right.
Exactly. All right. So let's go through a quick example here. So below is an example of how bitinformatics can find the existence of pattern within a data series that is specific to a single block. So bitinformatics is a new term that just describes the act of discovering a pattern within Bitcoin's blockchain, or within Bitcoin's blockchain.
Yeah, we've found ourselves like engaging in this activity pretty frequently. Like we're just sitting around just like messing around with data and trying to figure out like some cool new shit we could find. Yeah. And again, like think of how this can be applied. Yeah. And we were like, dude, this is pretty cool. This is like a whole new thing people do now. It's like we need to give this a name. And then I started thinking, it's like this happens in biology. Right. Bioinformatics is like a whole field of
interdisciplinary. Yeah,
it's about looking at the genetic programming and trying to identify patterns with that and attribute like a whole biological process to the existence of these patterns.
Yeah, I was going to say that bioinformatics is a real word.
Yeah, it's a real field.
Yeah, it's a field.
You can go work there.
Yeah.
You can get a degree and like help, it's cure diseases. That's right. By again engaging in the practice of bioinformatics. We're like, you know what? Let's just give it a spin. Yeah. A little nod to that human effort to find, organic value in organic code. Yeah. We're like, yeah, dude, let's just
bitinformatics just makes sense.
Yeah. So we've already labeled you guys the first ones who are tinkering with DMT and trying to come up with like, a value proposition as bitinformaticists, That's what I like to think of you guys as. So yeah, this is it, dude.
All right. Okay. So here's an example using block 817. This is just a random block. Yeah. you can find separate patterns to use for your dot element inscription in the transaction hash field number 16. So a pattern of 69 occurs 1,088 times within this block. For example, another one, pattern 420, occurs 58 times within that block.
You're such a memer, dude.
All right.
You picked the memeiest of patterns, but you know what? I have a feeling these are going to be pretty popular.
Yeah.
You know?
So by the way, these are not inscribed. They're just
No.
an example. So those of you who are fast enough can do this.
Yeah.
All right. So I'm going to give it some random name for the first one, Satoshi.69, which is my pattern. My field is 16, which is the transaction hash dot element. Same thing with Finney for 420. And I used ordinals.com. I looked at a list of transaction hashes within this block, 4,000 transactions. And then I did a quick search for how many times does 69 occur and how many times 420 occurs. And I got a quick number.
Mm-hmm.
So when this is in practice and Track has already implemented this search functionality, as soon as you find an element, eventually some interface like mscribe or wherever, they'll tell you is like that element occurs X amount of times in the entire Bitcoin blockchain. And so this will tell people, projects, it's like, oh, this occurs 1 million times. I can use that for my token for my game.
Yeah.
Or I can use that for DeFi.
Correct.
Right? And so that isn't ready yet, but it will be.
Yeah.
Because Benny's like the fastest gunslinger out there.
He really is. Yeah, and he gets it.
Yeah.
And he's in full support of this. So, and this is exactly the type of showcase, I think, of what tap enables and such. So this is right up his alley for sure.
All right, so we got the element. It's like NATs is NAT deployment is one application of digital matter theory where anyone can create hybrid tokens on Bitcoin whose token existence parameter are determined through reference.element inscriptions. So here's kind of an overview of how all of this will work. So I mentioned, right, the element must exist. Projects, deployers are going to point to that element, and then they're going to create non-arbitrary tokens from the deployment inscription, right? This is very standard. It's the same way TAP exists, BRC20s exist. Every single fungible token exists in a very similar format. And NATs are no different. All right, so we talked about how NATs have an expansionary supply, so this goes into detail for that. But it's very important that NATs expand the supply because it's scalable. People who deserve some sort of token based on the block data can inscribe that 1,000 years from now, right? You don't have to wait on some sort of airdrop or some human to push a button to send or run out of tokens in that scenario or whatever.
Yeah.
So it's very important. So what is a hybrid token? So we might be going into too much detail. Should we keep going?
I think so. We're almost towards the very end here.
Okay. All right. So hybrid tokens. Oh, why invent this new word again, right? We got bitinformatics, we got hybrid tokens. Well, this is what happens when you deploy a mint inscription from a project. So for example, we have a mint inscription, tap mint Satoshi, when I'm gonna own block number 1 from this mint from a deployment inscription. And it says here, the following inscription could represent 10 units of a Satoshi. But if you look here, you come in and you say, I'll own number 2. My inscription of 1 and your inscription of 2 are non-fungible tokens. They're different from each other. They're unique.
Yeah.
However, at the same time, they represent different units of account, right? Based off of the block data.
Yeah.
So I just used arbitrary numbers here just to illustrate the example.
Yeah.
But my point is that when you inscribe this, when you mint a token, you are minting NFTs that also represent the fungible aspect that represent the pattern that you're inscribing.
Okay.
Right.
So it's basically where we're like.
So these are therefore hybrid tokens.
Right. It's a system for block ownership, right? It's kind of like we saw this with bitmap.
Yeah.
In a sense, it's like we're starting to see like different token derivative products that are starting to, or propositions, I guess, that are starting to proliferate throughout the ecosystem. Is like, hey, you guys all have bitmaps.
Yeah.
You've already claimed ownership of a block. Here's this arbitrary token that can be claimable for whatever reason, right? Even though each bitmap is different, they have their own rarity components to them. They just arbitrarily set like this fungibility qualification to them, right? So
that's right.
This is kind of like a systemic way to kind of like build that into like a cohesive digital asset. Right?
Yeah.
And that's hence the hybridization aspect.
Yeah, and as a result, this fungible unit is a non-arbitrary. So if you own this block and this block is representing some sort of field,
depending on that deploy inscription, right?
Depending on that deploy inscription, you get this non-arbitrary unit of Satoshis.
Yeah.
Right. And so that's the example. All right, so let's get to deploying, right? Let's actually deploy a project or a deploy inscription. So creating your own NAT is deploying an NAT is a simple JSON inscription that references an element inscription that you want to use for the foundation of your NAT. So step 1, use the following JSON to deploy your NAT using any text inscription platform. So you can eventually you'll be able to go to mscribe, but you can go to any of your favorite text inscription platforms, Unisat and whatsoever.
Yeah, this is definitely Domo definitely set the precedent here. Like the ordinals, like we're all JSON enjoyers basically.
Yeah.
We're all figuring out new clever ways to, I guess, implement new possibilities to this coding framework, right?
Yeah, yeah. All right, so here's the structure, right? We have, and everything is described here. We have the tap. We have a new operation, thanks to Benny. He's going to employ this DMT deploy structure here. You're going to point to the element, right, via a reference inscription. So literally just replace this text here with the inscription ID of the element that you're pointing to. Mm-hmm. Give your project a name, could be anything. There's going to be a couple of limits here, but all the details are in this chart here. And then there's this project ID. So we're going to talk about this a little bit more, but if you wanted to deploy a token on top of the bitmap ecosystem, just point to the very first bitmap, which is 0.bitmap inscription.
Yeah.
Right? And then dimensions and then data types. And so this is too deep for the scope of this discussion, but all this stuff is here. Just you read it, it'll make sense.
Yeah.
And then now once this is deployed, you just go to copy, paste, deploy, and inscribe, and you own it. And now you can create, now this is deployed. Now people can mint your token.
Correct.
So now let's go to minting. Minting tokens from DMT deploy inscriptions. It says use the following JSON data to inscribe a block associated with the ticker name. So in this JSON data format, using any text inscription platform, locate the inscription ID of the token deploy inscription and add that to the deploy between the quotes. So basically, this is your mint inscription, right? It's tap, it's token mint, so that doesn't change. You're going to point to the project deploy inscription ID, right? Very simple. And then you're going to type in the ticker of that project, right? And then here's the fun part. You're going to pick a block.
Yeah.
Right? So literally everyone's inscriptions will be exactly the same. They're going to be exactly the same. The only difference is you're changing this number from, block number 1 all the way to block 817,000 that already exists.
Correct. So that could mean a lot of different things depending, again, on that deploy inscription and the pattern that it's referencing, right? Like in our case, in the for the token that we're going to, I guess, initiate all this, set the precedent with the first NAT deployment. Yeah. We consciously chose a data parameter that has like as broad of an equitable distribution for the fungible token. So it had to be something that was had some consistency to it across every single block.
Yeah, from block 1 all the way to block 800,000.
Right. So there's not going to be too much like, if you guys remember back to the bitmap days where you wanted to do your due diligence and like look into every single block you were interested in inscribing just to know relevant details within that data parameter set, which is transaction count, right? You wanted to know, were there a lot of transactions in this block? Were there very few? These were things that like dictated your decision to claim this block, right?
So, and maybe you care a lot about this project that someone deployed, and you say, well, I want to own, the rare blocks, right? 2016 or 210,000, right? And so, you can do that. So first is first again.
Correct.
All right, and of course, Benny is going to be providing the NAT account balance. Within minting NATs, you are owning blocks that represent the DMT deploy inscription. When you own a block, you own all the fungible tokens of the pattern set from just the DMT deploy inscription. Remember, there's going to be dozens, thousands, hundreds. I don't know how many deploy inscriptions are going to be.
Yeah.
But if you own a block, you own a block from the DMT deploy inscription of that project. Okay. Finally, token transfer. Very simple, transferring tokens. So as soon as you mint a token, you can transfer X amount. So you just got to make sure that it's under the amount that you actually own in your account balance. So this will be kind of a little bit more obvious once Track is indexing everything, and it'll be much clearer how many tokens you have. All right. So use cases. So here in this image, and we're almost done here, and make sure if you guys are still paying attention, you're going to want
Who wouldn't be, dude? What do you mean?
You're going to want to wait till the end because the first token has been deployed as a demonstration.
Yeah, we're going to show it too, right? We have them like on deck. Can we like observe, put our spectacles on these things pretty soon?
Yeah, we can.
Okay.
All right. So there's 3 methods, and it's not limited to just these 3, right? So, but there's 3 methods that you can deploy your actual mints, right? So you can do a free mint distribution exactly like a BRC20. Just go to any inscription platform, type in the text, and then just hit enter, and you've inscribed and you minted something, right? Yeah. So that's the method 1, which is called fair. Method 2 is called function, right? So once you deploy your inscription, you can create a token authorization, send that to mscribe or any platform that supports this particular functionality. And now you can create functionality based off your token. So let's say you've upgraded your character in some Web3 game, and you've earned a new weapon type, right? Which is based on non-arbitrary tokens. And if you've earned that weapon type, you can go to my website and claim it. And so what it is you're creating a child inscription of the token authorization because the reason is because you've made that achievement in some logic from this particular project. Wow. And so you can apply this in dozens of ways. I just gave one, right? Yeah. And then finally we have method 3, which is provenance. For the bitmap people, you're going to want to pay attention to this part. Yeah. Because we've deployed one element, 2 projects. Those 2 projects is a fair mint distribution and a bitmap token, right? So how does provenance work? So basically, we deployed a project, and we said if you hold bitmap, you can inscribe a token based off of this particular pattern of this element. And if you hold it, you can inscribe it 1,000 years from now if you want to wait that long. Yeah. Or you can inscribe it today, right? But it's well, I should say. So Benny was like, "You want to wait on this part, but I think it's ready." So, okay. But the point is that whatever this element pattern is, let's say you own 100 million tokens, you can from your bitmap create a child inscription using the existing child inscription websites, and you can mint this fungible token as a child inscription from your bitmap, representing the token of bitmap, right? Yeah. That's what it is. Yeah. And it's not an airdrop. It's what we call it in the document. It's called a block drop. Yeah. And the reason why the difference between an airdrop is like, first, an airdrop is like, let me set an arbitrary amount, 1 million. Yep. Right. And then the logic is if you hold bitmap, you can claim one of these. Then you got to set parameters. Like if you hold this bitmap, it's worth 10, and if you hold that bitmap, is worth 100. Like it's arbitrary, right? Yeah. And then eventually, let's assume it gets minted out. Then what happens for people that get onboarded tomorrow? Yeah. After that, yeah, it's like they're just left out.
Pretty much, yeah. So it's definitely not future proof, and it doesn't. I guess the existing token distribution models, they're not necessarily conducive to what it is we've identified as what is truly valuable about bitmap and ordinals and rare stats. It is the digital matter theory application, right? The fact that there's non-arbitrary roots to this value genesis. Yeah. Right. So why wouldn't we apply or expect those same principles to underline the fungible token side of these ecosystems, right? Like they should emerge from the same DMT methodologies. Right. Right. So in the absence of this framework, that really wasn't possible. So up until now, now that we've devised a whole open source standard basically, where anybody can kind of, again, point to the provenance, the existence of bitmaps, and then identify new potential values based on the patterns that exist within them. And again, create this avenue called block drops, where new digital commodities can be basically discovered.
Yeah,
and
infinitely scalable
and
too.
owned as a result. Yeah.
Yeah, so someone who owns a block 1,000 years from now, if Bitcoin is still beating, right, they'll be able to own that block and then go and inscribe a non-arbitrary token that was minted 1,000 years ago.
Yeah.
Like, how cool is that?
It's the coolest, dude. I think it's the coolest.
Hell yeah.
So we're going to see, I guess, the response. And yeah, this is not to, again, we wanted an equitable distribution of these tokens, and so that's why we chose the field we did, which is the element, I think is the 11th field, which is bits.
Yeah, bits, correct.
So we started off thinking like we wanted to select the nonce value of every block.
Yeah.
But then we realized like there's a little too much randomness. There's too much discrepancy between blocks if we would have done that, right? Mm-hmm. This is kind of just to kind of like give you guys an idea of the thought process that goes into, I guess, like ecosystem design.
Yeah.
Whenever you're discovering patterns and figuring out how to, derive utility from that discovery.
Correct.
And we're like, yeah, this is the first token. This is an ecosystem token. The bitmap's already distributed. It would be kind of like feel not right if somebody were to come in and like find out that the block that they own it's got 100 tokens, 100 BMT tokens in it, when this other guy has like 6 billion or whatever. Right. It's like, fuck, dude, I got the short end, didn't I?
Right.
So we intentionally, again, consciously decided to go with the data field that, had much more
equal distribution.
Yeah, broad application. So
yeah,
and that's just us.
Yeah, and this is just for demonstration purposes, right? It's just to showcase that this is functional. You can do this today.
Yeah, you could derive. We've already seen it on Twitter. People somehow are already thinking of like
they figured it out
without us even dropping anything. It's like they're already kind of like theory crafting their whole like parameters.
Yeah.
Based on DMT principles, and it's very interesting to see.
And the winner, like the token that gets the most adopted, is decided by the invisible hand, and that's how it should be.
Mm-hmm.
All right, so let's talk about the first element that's been deployed. So this is an active deployment. This is live. It's DMT, so we gave it a name. It's called DMT, of course. And it's in the field 11, which is the bits that you mentioned earlier, data element. And so as you can see, this one doesn't have a pattern. It's because we're invoking the entire field.
Mm-hmm.
And so now it's officially deployed. And by the way, it's deployed using an inscription on a block 9 sat.
Yeah, shout out to Rare Sat Society for sending us those block 9 sats. We had a delightful interview with them, and then man, we discovered how like badass his like Rare Sat inscription platform actually is, dude. It was very like simple to use.
It was easy.
Yeah.
Like I basically just inscribed on top of block 9 a text, and that was it.
Yeah. And so it worked swimmingly.
Yeah.
So yeah, I mean, definitely if you're ever looking to, I guess, leverage more DMT principles and, find a good non-arbitrary canvas to deploy your digital assets on top of, I would definitely recommend this for sure.
So yeah, there's the DMT.11.element, and this is on block 9 sats. And then of course we got the 2 project deploy inscriptions already minted as well. These are, by the way, also on block 9 just for the
just maintain the provenance, dude. And it's for the culture, really.
Yeah,
I mean, we're all DMT here.
Yeah.
So we all got to support each other's digital matter initiatives, in my opinion.
Yeah. All right. And so, of course, in addition to the first NAT token, by the way, anybody can go and mint this at any moment. You can also mint a BMT token if you have a bitmap.
Yeah.
If you have a bitmap, you can inscribe this token, and it's going to be a child inscription of your bitmap. Mm-hmm. And so there's no real rush to do it.
Mm-hmm.
But the point is that, hundreds of years from now, when people start onboarding to bitmap and start doing stuff with bitmap, they'll be able to mint this token.
Correct. So, I mean, yeah, definitely check out the description after watching this video, lads, because this doc will be there, correct? And it's going to be a full breakdown, a step-by-step, minting procedure, what exactly it is you need to copy and paste, I guess, to start, claiming or, participating.
Yeah. And so finally, supported token protocols, of course, TAP protocol. Mm-hmm. This theory can be applied to any chain, any protocol, or anything like that. And so
correct.
We'll be updating this as it comes if people really care about it. If not, I mean,
this is
got Benny.
Correct. Yeah. I mean, we're thinking, because just based on like the inscription virus that we've been seeing, every single layer one chain is kind of like adopted the principles of digital artifacts, right? And
Yeah.
not every blockchain it can support ordinal theory though, right? But still, there are principles to digital artifacts that can be, I guess, architected and employed onto other chains, and we're seeing that almost every chain now has some variant of ordinal theory deployed, and digital artifacts are now, obtainable on those chains. So we're expecting, again, we're setting forth these principles of digital matter theory, and we're leveraging the existing, token environment of TAP to make it in the most efficient way possible, within the scope of what's available. But we're not. But our prediction is this is going to, I think, trickle out.
Yeah.
Similar to how ordinal theory did.
Yeah.
In our opinion,
ordinal theory is going to be is being applied to other chains in the same way that we believe DMT is going to be applied to other chains.
Yeah, just anybody. Yeah, so it's not going to look the same. Just like these inscriptions on different chains don't look like ordinals, but they abide by the same principles. So
that's right.
How NATs are achieved in other token systems to be determined, but that's the ultimate wait and see experiment, right?
Yeah, 100%.
That's the call to action to you devs, right?
Yeah, so we have a little bit more work to do, because on this page here, NAT Method 1 Live, we wanna create like a section here of how to mint, and there's a link here, but you just basically copy text here, go to any text inscription platform, pick a block, submit that inscription, and you own that block, right? It's that simple. And then again for BMT, if you own bitmap, because this is a block data, not transaction hash data. If you own just a generic district bitmap, you can create a child inscription of that bitmap to represent your fungible token.
Yeah.
Right. So that's it. I think
grand takeaways, dude.
Yeah. So
I guess, man.
Yeah, this is huge. Finally, we've been.
I know.
By the way, let me show you guys something. This dot element inscription. If I can zoom in here. I inscribed this back in June 26.
Yeah.
Like in mid blockout.
Yeah.
Because we had like this concept of this
brewing
theory.
Essentially. And we knew it had some serious legs to it, but it took a while to refine it into something that we think was applicable.
Yeah, and a lot of this stuff didn't really exist. Like parent-child inscriptions wasn't really.
Yeah, TAP wasn't even really
around,
devised at the moment. So it was like, yeah, there was a lot of infrastructure components that still needed to kind of fall in place in order to even find a pathway.
Yeah, and even then we weren't fully clear as to how this should work and look.
Yeah, and it's the reason why we've been so vocal and open about this. We've been tweeting about it for the last 4 or 5 months.
Yeah.
We've been making videos about it.
Yeah.
We've been mentioning it. We've been, what's the word? Bombarding people that we're interviewing is have you heard of DMT yet?
Yeah.
And the reasoning for that was we were hoping to maybe spread a seed, and somebody would have captured that seed and kind of just took off with this. And before you know it, you'd have some anonymous figurehead like Bitoshi, Natoshi or something like that. It would have just done this and architected this framework. But I guess we waited around for a while to see if that would happen.
Right.
The seed definitely spread because we're seeing this, the concept gain a lot of appreciation, but nobody dropped the doc yet. So God, I guess we're going to have to do it.
Yeah.
Dude.
Yeah.
It's
on us.
It's our task. So this is our best attempt at that.
You know what? I forgot to mention. This is sort of important because Bitoshi, such a critical contributor to this concept. It's so critical that Bitoshi did this without the schematic, without this document. He did the exact same thing. Because if you were to do bitmap all over again, go back in time and then leverage this documentation, what you would do is you would pick the number of transactions as your pattern, right? And your number of transactions is somewhere in here is NTX. And so you pick that field, you deploy that project inscription with that field, and then you say, if you own block, you own a piece of the metaverse.
Yeah.
Right?
Yeah.
And so he did it a little bit more differently only because this schematic didn't exist. And but you could essentially redo bitmaps under this scheme, and it's literally like the carbon copy. Right? So it's just interesting that we we just basically discovered this, right? This is like not an engineering thing; it's a discovery.
Yeah.
So I just thought that it was like an interesting sort of like, kind of like understanding, right?
Yeah.
But yeah, that's it. This will be in the description. Definitely read it. Give us comments, feedback. Let us know, if you're going to be deploying projects and elements, and all this stuff is going to be supported on mscribe. So wait for an update.
Definitely. Yeah. And like, this is, it's going to be exciting to see, like, again, I'm anticipating pretty quickly after the release of this video and the docs.
Yeah.
We're going to see some deployers, some new bitinformaticists. So yeah, definitely let's get this ball rolling, guys. And I mean, that's the whole point of this bull market, right? That's coming up in front of us. We're supposed to be experimenting with Bitcoin and see what's the new value we can derive that hasn't been attempted before.
Yeah.
So this is it. Yeah,
that's it for us. Let us know if you have any questions. We respond to everything on YouTube, obviously on Twitter, and let us know what you think. And, which project you're going to be creating. Make sure you follow us on our Twitter. Make sure you subscribe. We're going to have alpha for the rest of like this bull run. So stick with us. I appreciate you guys for watching, and we will catch you in the next video.
Peace.